graph of cosecant and secant look like? Now, before we jump into the cosecant, I want to remind you that cosecant is the reciprocal of sine. And so I want to begin with the sine graph, which you may remember in my previous video. I'll be sure and link it in the cards. But my sine graph starts at 0, 0, and then it goes up to pi over 2, 1. And I've got those 5 key points that I pointed out were very important for you to know. And I'm just going to do like this so we can kind of have a reference point for what happens with the cosecant graph. Now, if cosecant is 1 over sine, it's the reciprocal of sine, then wherever sine is 0 would create a 0 in the denominator. And that's a problem because we can't divide by 0. So I'm going to put an asymptote wherever the sine equals 0. I'm also going to go ahead and tell my domain that x cannot equal those values because we have a vertical asymptote there. Now remember, we're just drawing a section of the graph, so I'm just using the dot, dot, dot to show that the pattern would continue. Now, where the sine is equal to 1, we would have 1 over 1, which is okay. We can have 1 over 1. So cosecant has this value here, and also the same thing happens at -1. So what does cosecant do between these asymptotes? Well, it looks a lot like a parabola. What would happen after 2 pi? Well, the next up parabola would happen, and the pattern would continue. So I like to put the sine graph in there so you can reference it, but it's just kind of a guiding point. Now, look at your cosecant graph. Think about your range. You've got these y values here that start at -infinity and go all the way up to -1. So we'll write that like this. Y is less than or equal to -1. Or, and then think about these y values. They're starting at 1 and going up. So we could say y is greater than or equal to 1. If you wanted to write those as an interval notation, you would go -infinity to -1 with a bracket, and then you would do, again, 1 with a bracket to +infinity. Now, let's talk about your symmetry. Remember, sine had origin symmetry, and that meant that I could rotate the graph 180 degrees and I would get the same graph. And so the cosecant graph has the same symmetry, and it has that it is origin symmetry, again, because it is an odd function. Okay. Last piece of information you need to know about cosecant is that the period, or how long the graph travels before it repeats. So how long from here before we get the next up parabola? And that is 2 pi. You'll remember that sine has the same period. Sine and cosecant both have a period of 2 pi. All right, let's turn our attention now to the cosecant graph. And we remember cosecant is the reciprocal of cosine. So I'm going to draw the cosine graph dashed here. Again, those 5 key points of my cosine graph. Okay, and remember, because secant is the reciprocal of cosine, we have a problem wherever the cosine equals 0. And that shows up as a problem because I'm going to do a vertical asymptote there. So this time I have a vertical asymptote here and here. That means that x cannot be those odd multiples of pi over 2. So pi over 2, 3 pi over 2, and the pattern continues. Now, wherever the cosine equals 1, no problem. I can do that. So I've got this upwards parabola. I would continue there with the pattern. And then down here at -1, I've got that down parabola just like the cosecant. Okay, so let me take off the cosine graph so it's not distracting us when we look at some details. Okay, we've already got the domain. Let's think about the range. We've got this down parabola that starts down at negative infinity and goes up to -1. So we could say that y is less than or equal to -1, or we start at this +1 y value and go up. So, or y is greater than or equal to 1. If you want to write that in interval notation, you can write it as negative infinity to -1 with a bracket, and then 1 to positive infinity. Okay, what about your symmetry? Now remember, we're only drawing one section of this graph, but it actually continues in both directions. Secant has the same symmetry as cosine, and that is y-axis symmetry, because both cosine and secant are even functions. Finally, the period. The period is how long it takes before the graph begins to repeat. And in this case, it takes us a full revolution on the unit circle. It takes us 2 pi before the graph repeats. I hope you're catching some of the similarities. Secant and cosine have the same period, the same symmetry. All right, let's turn our attention to the cotangent graph. Now, you'll remember our tangent graph. We had x-intercepts at 0, pi, and 2 pi. We had vertical asymptotes at the odd multiples of pi over 2. So that's pi over 2, 3 pi over 2, 5 pi over 2, and so forth. We said our range was all real numbers, and our period was pi, and the symmetry was origin. Now, cotangent. So cotangent is going to be similar to tangent, but slightly different. So cotangent is the reciprocal of tangent. So that means wherever tangent equals 0, we have a problem. So tangent equals 0 at 0, that means I have a vertical asymptote there. Tangent equals 0 at pi, that means I have a vertical asymptote there. And also at 2 pi. That means my domain, x cannot equal those multiples of pi over 2. All right, now we have x-intercepts at the odd multiples of pi over 2. So we've got x-intercepts here. And you remember the tangent graph looked like the x cubed graph, that snake shape between the asymptotes. Cotangent does as well, but it's in a negative direction. So it's in a decreasing pattern. So it looks something like this. So now the range you can see is all real numbers. Remember, if you want to write that in interval notation, a negative infinity to positive infinity. Your period, how long before this graph repeats? That's right, it repeats every pi. And then the symmetry. This symmetry also is origin symmetry. So you see a lot of parallels between the tangent and the cotangent, but I also want you to notice the differences so that you'll be able to make the transformations with these graphs moving forward.